Hey, I'm going to introduce you point of sale code kata implementation. Source code you can see here in my GitHub repo. So right now I've cloned this project to my local computer, and here I'm going to introduce you all implementation details. Source code is written in Visual Studio 2009 with a C# language. Original description is here, where we need to implement a grocery market line or bucket, and also apply discounts to some products depending on the amount of the product we have in a bucket. Also, there is proposed API description for our point of sale terminal, as well as 3 mandatory tests which should be run or should be demonstrated as implementation verification. In the README file you can see some descriptions, like a link to source code, implementation details, several problems I have discovered, several improvements probably need to be done in order to make this product, this demo a bit more awesome than it is right now. So let's go from the beginning. I'm going to introduce a solution structure. There are 3 projects: point of sale library, together with tests, and also a console runner. This is a console application which allows us to do live testing or live verification from a command line. So let's get back to description. During the implementation, I have implemented 3 possible ways to calculate whole bucket price. So the first one and the simple one, the simplest implementation, is where no discounts are applied, right here. So only base price is taken in consideration. To make a demo of this simple calculation, I have a set of tests here in a test project into a simple folder, where it's possible to run all tests in order to see that 3 mandatory tests are okay. Plus, I have one specific test which says that no discounts is applied. From the testing point of view, we have a setup of our point of sales terminal. We are injecting a simple bucket handler, then we scan several products and verify that amount is correct. This is for A, B, C, and D product. This one is for 7 C products, which cost $1. So when discount is not applied, then expected result is 7. Different set of products without any discounts is 14. And also, if I have 13 C products, then amount is 13 as well. So this is just a first one and simple implementation where no discounts or no additional prices are applied. I will run tests once again. Perfect. Now, in order to make this sample to do whatever is described here, I have 2 possible implementations, which I called replace and divide. So the idea of replace strategy is we do replace item in a bucket when we have amount which allows us to have a discount. Let me show you replace strategy tests they are the same, but expected results are different. When we have single set of single product of each code, we have 725. When the price is applied, we have 6 instead of 7, because six items cost $5 plus 1. 5 plus 1. And also this set of different products with expected result, and additional test that discount is applied only once. So for this set of products we have only one applied discount. For other set of same products we also applied only once. And then product C with original price. It's possible to see, let me run tests first of all. Here they all tests of that test case are green. It's possible to see how does it work in live in a console application. So this is implementation of the proposed interface where we have point of sale terminal, then we set prices, then we add codes and calculate total. Let me run this application. Here it allows to enter a products A, B, C, D, for example. Press enter, and we have our total, and also we have a state of a product in a bucket. We know that according to original task, product A costs 3 for 3 items in a bucket. Let me repeat this test live, like here. Let's imagine I've set 2 items in a bucket. We calculated total amount without any discount. But if I set 3 items in a bucket, we are replacing each item in a bucket with a new item in a bucket with a different price. So this replace strategy, where in a bucket I do replace original items and then calculate total of the replaced items. It will work as well like this. Let me add 3 items of single product, of one product. 6. 1, 2, 3, 4. How many? 1, 2, 3, 4. 6 items of other product with a discount. Let's say couple products without discounts. Here we can see that first 3 been replaced with a discounted, then replaced with a discount, and then several items being added without any discount. Now I have other strategy which, instead of replacing items in a bucket, just decrease original price of a product. Here are tests for this. I can run all tests. They also probably green. To make it live, I can, in my original program, inject specific strategy with a divider like this. Oops. If I run this console application, I can see that 2 items are added with original price, but 3 items, oops, we don't have price here. Okay, total is 3. I see. 5. Let's add 1, 2, 3, 4. So it should be 3 with original, 3 with discounted price, and 1 with, yeah. So here 4 items in a bucket, 3 of them goes with a discounted price and 1 with original price. Total probably is correct. Now let's go deep in the implementation details. Here in the library I have point of sales terminal interface with its implementation. The main idea here is to have specific calculator or handler injected inside of the point of sale terminal. Here we just forward all calls to that specific handler. As I said, we have 3 handlers here in a bucket. We have description or interface of a bucket handler where we do have calculation, scanning, and getting what's inside the bucket. Also, some base logic is implemented in the base abstract class. In, for example, when we're trying to get bucket, we're just providing a bucket, and we are trying to find an item. Here we also find by a we need to find a product by the code. We have this base logic. Also, the whole container of all items in a base class implemented in the base class. Simple implementation looks like while trying to get a sum of a bucket, we're just aggregating a price. When we're scanning, we are trying to search for a product and then create a new bucket item and add it to a bucket. 2 implementations with the discounts are here. First one with a replace strategy, where we have a specific status of a item in the bucket. So if the bucket is not been yet replaced, we are getting the we are calculating total of all items which are not replaced, so we are skipping replaced items. When we do scan, we are getting product, then we verify that we can apply extended price, and then we apply extended price. Can apply means that we have in a bucket items which are not yet applied, as well as amount of products is equal to the amount which is in our price list. Other implementation here, where we have calculate total without taking in consideration state or status of the item, because we don't have statuses here, as well as a scan implementation where we verify that we can apply extended price here with updating original price, which is new one, which is item of in extended price divided by the amount. Probably that's it. Here we have simple implementation with replacing and implementation with a division. Now, according to problems, first problem I have found out that in the current implementation bucket is not thread safe. It means that we cannot add and calculate total amount in a not thread safe solution where update and adding where bucket manipulation is performed from different threads. Also, this implementation does not include any exception handling, as well as the current implementation doesn't validate input parameters. Probably all of these could be added as a second stage of the demo. Now, in order to improve current solution, I can see that, just a second, I'm going to show you the price list implementation. Here we have a product, we have a product code, base price and extended price. So idea of the improvement here that we have only one extended price. But what if we allow to have several extended prices, like single product cost this amount, 3 products cost this, and 6 products cost this. So instead of having a single extended price, it will be possible to have a list of extended prices and then specific strategy to calculate which extended price is better from the number of extended prices. Second improvement is a compound discounts, like single product cost some amount, but if you get other product together with product A, you will have a discount for the original product A. And last improvements, current tests, they don't have any failed behavior or expected failures implementation. So here, if we run all tests, I do test only success flow. Here, only success flow for all 3 cases, and for items in a test, I don't test any failures or expected failures. So if I rerun all tests, here it's only happy path testing. Probably that's it for a demo. Thank you very much. It was really interesting to do this type of implementation, and I probably covered everything what I would like to have in the current solution. Thank you very much. See you.